In this video, we're going to be looking at section 2.6. Domain, range, and intervals. Now, the whole idea behind this section is to kind of get a better understanding of just how the quadratic works, and we can do this pictorially. So first we'll need a few definitions, and then we'll dive in. So our essential question is, how do I find the domain, range, and intervals of a quadratic? So first we'll need some definitions. We'll start with domain. Domain is all the possible x values. And for quadratics, it's this part's quite easy because it will always be the same. Always all real numbers. That's our symbol for all real numbers for quadratics. So you just have to remember that. If I'm asking for the domain of a quadratic, you just write the symbol for all real numbers. The range is all the possible y values. And for the range, it's not quite as simple. We'll use the vertex. We'll just use the vertex. Use the vertex to find the range. Now we're going to talk about our intervals. And there's two intervals we're going to look at, but there's important things we need to note before we look at them. One, always use the x values. And two, always read it left to right. So we'll always use the x values, and we'll always read it left to right. The first interval I want to look at is increasing. And that's where the graph is going up. And then we'll have the other one will be decreasing. And that's where the graph is going down. Okay, so let's see if we can identify the domain, range, and the intervals, increasing and decreasing. So we'll have to draw a graph. We'll use graphs to help us do this. So you'll be given a graph. And the graph could look something like this. Now the first thing I'll want to do is identify the vertex. So we look at that, and we want to kind of give that point some values so that way we know what we're working with. So let's identify it as the point 2, -1. So let's find these 4 ideas: domain, range, increasing, and decreasing. So the domain for this one is all real numbers. That'll be true for every single quadratic that we look at. Any x is available to us. I can go left for infinity and I can go right for infinity, so all x's are available. Our range I'm talking about the y's, and my lowest y is now -1. So I have y values that are always greater than -1. So we can be greater than or equal to -1. So that's our range. -1's included, so I have the equal to, the line underneath, and I can be any y value as this goes up forever on both sides. So our range will be y's are greater than or equal to -1. Okay, now we're going to do increasing and abbreviate it. So now I'm increasing from when x is 2 I'm increasing from when x is 2, and I'm going all the way to infinity. X can be positive infinity. So we start increasing at 2, and then I'm talking about x's. So, and then I go to infinity. So this piece right here, 2 less than x less than infinity, this less than x less than will be on all your intervals. Every interval will have the less than x less than. We're only going to use x values, and we have to give it a beginning and an end of our interval. So our beginning of increasing is 2, and then our end is infinity because it will increase for all x values into infinity. And then we'll have something that looks quite similar for decreasing. So for decreasing, I'm starting, if I think about the x values, how it's going forever left, I'm starting at negative infinity, way out negative infinity, and then I'm decreasing to 2. So I'm starting at negative infinity, less than x, always going to be the less than x less than, and I quit decreasing when I get to 2. And that's how we can find the domain, range, increasing, and decreasing. Okay, now I want to do one more example. We're just going to flip a graph upside down. So let's go to this point right here. We're going to draw a parabola. So the first thing I want to do is identify my point where I'm at -2, 2. So let's identify that. And now we can find our domain, range, increasing interval, and decreasing interval. So our domain for all quadratics will be all real numbers. Our range, so where's my y value starting, and then are they going up from there, or are they going down from there? I'm starting at 2, and then I'm going down. So y will be less than or equal to 2. Because now all my y values are going to be less than 2 as I go down forever. So I can have any y value as long as it's less than or equal to 2. And that's what our range is representing. And then we'll have increasing. And now we're increasing starting, I'm thinking about my x value, so I'm going, even though it looks like I'm going down, I'm really thinking about how I'm going left this entire time. I'm really traveling left in my x direction. So I'm starting at negative infinity, and then I'm traveling, the x's are traveling until we get to this value, this x value, that -2. And then my decreasing, well, where do I begin decreasing? Well, I begin decreasing at -2, and then I'm thinking about how I'm traveling right forever, not down, but how it's going right, and that's going to take me to infinity. So I'll start at -2, less than x, less than, and then I go to infinity. And that's how we can find the domain, the range, and our intervals, our increasing and decreasing intervals, just by looking at the picture of the quadratic, the parabola. Well, thank you very much for watching this video, and I hope you have a great rest of your day.